Welcome back, everybody. Last time we got introduced to the idea of polar coordinates, this different way to give an address to each point in the plane. Instead of using just horizontal and vertical position, our x and y coordinates, polar coordinates work by giving an angle off the positive x-axis and then saying how far out in that direction to go to get to the point that we're talking about. We did a number of things, including looking at our formulas that help us translate between polar and rectangular coordinates. We also started looking at some solution sets to equations. We looked at solution sets to our coordinate equations, r equals some number, theta equals some number. What we're going to do today is look at graphing solution sets to general polar equations, where we have r equals some function of theta. And this was the curve that we saw last time, gave us a circle, and we saw this through taking our equation and translating it into a rectangular equation using our formulas. Today, we're going to see what I'll call our main method for actually sketching these curves, which is to follow polar instructions that we get from the r-theta plane. And today is about just kind of feeling out what do I even mean by that and putting it to work with some examples. So let's look at this equation here, r equals 4 cosine theta. And so to start, I claim that let's just forget about polar completely, and let's just graph this as we would if this was 4 cosine x equals y, right? Just with theta as our horizontal axis and r as our vertical axis. Let's start there, and I claim we'll be able to figure out from that what our curve looks like. So here, I've given us our graph of cosine of theta, right? Cosine starts at 1 and drops down to -1 and then comes back up to 1 at 2 pi. And so halfway is going to be pi. Divide that in half, then that's pi over 2, and over here this angle that's going to be 3 pi over 2. But we don't want a graph just of cosine, we want a graph of 4 cosine theta. And that's going to take our cosine function and stretch it by a factor of 4. And here we can do a little magic trick and get a graph of 4 cosine theta just by adjusting our axes, right? We've seen this before when we were playing around with parametric equations. All right. And so with this, we now have a graph of our r equals 4 cosine theta in the r-theta plane. And what I claim is we can now use our graph to get some nice anchor points and then connect them using the instructions that our curve gives us. So let's see how that looks. At this first point here, this has horizontal coordinate 0 and vertical coordinate r, and so that gives us theta is 0 and r is 4. And let's just go down and real quick record the coordinates for all of these anchor points. Next one is theta is pi over 2, r is 0. Down here, theta is pi, r is -4. Here, theta is 3 pi over 2, r is 0. And then the last one over here, theta is 2 pi, and r is 4. Okay. Now, each of these I claim is telling us about a point in the xy plane that satisfies our equation, that has r equal 4 cosine theta. This first point here with theta equals 0, r equals 4, we can graph, right? Over here on the x-axis, that's when theta equals 0, and we just come out 4 in that direction, 1, 2, 3, 4, and so our first anchor point shows us that this is a point on our solution set. Our second anchor point has theta up to pi over 2, so we imagine our big arrow, right, pointing along the x-axis, we crank that up so it's pointing along the y-axis, and r equals 0 tells us we don't go out anywhere. Actually, that just gives us the origin. Well, what about this next anchor point? If theta is pi, that means that our arrow is actually pointing along the negative x-axis. And r equals -4 tells us to go behind that. So we'll go out the opposite direction out to actually this same point that we had at the start. The next anchor point has r equals 0, back when our angle is 3 pi over 2. And so we're looking down here and we're getting r equals 0 again, which hands us the origin. And our last anchor point comes from when our angle is now 2 pi. We're again looking along the positive x-axis, and r equals 4 tells us to go out that direction 4. And so we've actually hit our 2 anchor points twice, and at least at this point, it's not clear how to connect these dots, right, just from what we've done so far. But let's rewind all the way back to the beginning, right, looking at moving from our first anchor point to our second anchor point. You can ask the question, how do we connect these 2 points? Well, I claim that we can read that off from our curve. If we look at our curve, right, the vertical here is telling us r. And so reading off from our curve, we can see that, oh, our r is going to be steadily decreasing down to 0 as our angle moves from 0 up to pi over 2. And so let's look at that over here. As our angle moves from 0 up to pi over 2, right, where my mouse is, that would be like if we just kept the exact same r at r equals 4. But instead, our r is going to be steadily decreasing, so as our angle increases, we're going to be kind of pulled in to the origin. And if we do that smoothly, so that when we get to pi over 2, we're actually down at the origin, it's going to give us something like this. Right, where again, here, let me kind of trace it in here. This would be what it would look like to keep that r equal 4 constant. But here now, at each angle, like at this angle, for example, we don't go all the way out to that r equals 4, we pull back a little bit, and we pull back more and more as our angle increases to pi over 2. All right, well, what about the next half? Well, before we do that, let's actually take a look at what we've just seen with an interactive here. Might be a little bit more convincing to you. So here on the left is the graph of our function, r equals 4 cosine theta, in the r-theta plane. And over on the right, this is our xy plane. And let's see what happens as we take our theta and drag it up to pi over 2. All right, notice we are slurping back until right at pi over 2, we're at the origin. And so notice how this works. Right over here, the length of this green vertical stick, right, that's telling us the length to come out, along this path here. here the positive direction for us, where our arrow would be pointing is kind of solid, and the dashed, that's the negative backwards direction. And so this is telling us we're coming out in the positive direction that amount. And as we increase our angle, we come out less and less until right at pi/2. We come out 0 and we're at the origin. Okay, well, let's think about what's going to happen afterwards. Well, here now, moving from pi/2 up to pi, right now our angle, our big arrow, is moving from the y-axis over to the negative x-axis. Those are the angles that we're thinking about. And what's r up to? Well, r is actually getting more and more negative, right? R is steadily decreasing down to -4 at the angle of pi. And so here, as our angle moves from pi/2 up to pi, our r is getting more and more negative. So we're actually coming out the opposite direction more and more until at pi we're actually -4. If we put this information together, kind of hard to come out the opposite direction just with the mouse here on the screen, we're gonna get this traced out. And we'll wrap back around. Let's look at the interactive. So here, as we increase theta from pi/2 to pi, right, our r is getting more and more negative. Right, we can see that on the left. We have this dashed line, right? That's showing us that our r is negative. And so here we're coming out in that negative direction. Right? As our angle moves from pi/2 to pi, we're coming out in this negative direction more and more until we come out 4 when our angle is pi. And at this point, we could continue kind of reading off these instructions and seeing what we do. In this particular case, what ends up happening is we just are going to cycle around this circle again and again. So if we rewind the video, woo! Right, that's how we can take a graph in the r-theta plane, get some nice anchor points, and then connect the dots using the instructions of how our r is changing between different angles to connect our points. And once again, we do see this circle that we saw algebraically we would get last time, centered at 2, 0 and radius 2. And so that's a nice little sanity check. Okay, well, the rest of the day today is just about putting these ideas to work. Getting a graph in the r-theta plane, getting some anchor points, and then reading the instructions from the curve to tell us how to connect the dots. Now, this is a great opportunity to practice trig without using our calculator. So let me encourage you to stash that away and just bust out your handy dandy unit circle if you need to think about trig functions. So what we're going to do the rest of the day today is graph these 3 solution sets of these equations. In this first one, I want to give us just a heads up about r equals 4 cosine 2 theta. This is almost the same as the equation we were just working with, except that where we had theta, we now have 2 theta. Now, first of all, I want to mention that this isn't just going to move us around the same circle, twice as fast. That's not how it's going to work in these kind of polar coordinates. We need to still follow the instructions from the r-theta plane to see what kind of curve we're going to get. We're actually not even going to circle at all in this case. Let me give you just a little head start here with how to get a graph of this function using our graph that we have already for 4 cosine theta. Right, this is the graph that we constructed just a few moments ago. If we want to now get the graph of 4 cosine 2 theta, well, what's going to happen is since we're multiplying this theta by 2, we're going to get to these horizontal tick marks twice as fast. So for example, cosine is going to become 0, not at pi over 2 anymore, but at pi over 4, right? Because we take pi over 4 and multiply it by 2, and we get pi over 2. And so what's going to happen is this is going to actually scale our theta tick marks by a factor of 1/2, because we'll be getting there twice as fast. And so here, instead of pi over 4, we'll get there at pi over 4 instead of pi over 2. Instead of getting here at pi, we'll get there at pi over 2. Instead of getting here at 3 pi over 2, we'll get there at 3 pi over 4. And instead of getting here at 2 pi, we'll get here at 2 pi over 2, in other words, pi. And so here, since we're only ending at pi, we'll probably need to continue the curve to get some more good anchor points and instructions. But here at least is a good start. And from this curve, we can figure out some nice anchor points, the points that those are talking about in the xy plane, and connect the dots using our instructions. So at this point, pause the video and go ahead and see what you can do with all 3 of these equations. Get a graph in the r-theta plane, get some nice anchor points, and then connect the dots as best we can using the instructions from our curve. All right, well, let's see what we get here. From our anchor points, our first anchor point has theta equals 0, r equals 4. And so we are the same starting point over here. Here's our theta equals 0, r equals 4 point. Our next anchor point is at r equals 0, and that's when we are at pi over 4. And so let me maybe draw that angle in. So at, here our angle has moved up to pi over 4. And at that point, we are at the origin. And what's happening between these 2 angles? Well, r is slurping downward to 0. And so here, as we increase our angle from 0 to pi over 4, our r is going to get pulled inward. So if we do that kind of smoothly, if we pull in as we're moving out, it's going to give us something like this. So that right at that angle, pi over 4, we're at the origin. Our next anchor point comes from pi over 2, and our r is negative 4 there. And so at pi over 2, so now we're kind of facing up the positive y-axis. Negative 4 actually brings us to down 4 in the opposite direction. And well, what's r doing between those 2 angles? R is steadily decreasing, getting more and more negative down to negative 4. And so here, well, to play that out, as we increase our angle from pi over 4 to pi over 2, we're coming out more and more negatively. And to do that, we're going to be coming up more and more negatively as we come that direction. It's going to move us like this. Over our next stretch from pi over 2 to 3 pi over 4, we're moving from pi over 2 up to 3 pi over 4. It's where our arrow is pointing. What's happening to r? R is getting less and less negative until we get to 0. And so here, as our arrow kind of twists to the left, our r, how much we're out behind it, is getting less and less, and so we're going to slurp back in. Now moving from 3 pi over 4 to pi, so from 3 pi over 4 down to pi with our arrow, what's happening to r? Well, r is getting more and more positive up to positive 4. And so if we follow those instructions as our arrow twists over to pi, we want to come out more and more in that positive direction, and that'll give us something like this until we get to the point corresponding to our last anchor point there at pi for theta, and r is 4. And so this curve definitely would continue. You can probably imagine what's going to happen. This thing is going to kind of wrap around like that and give us this nice, pretty kind of almost like rose shape. Let's see this happening with our interactive. So if we increase the t to be 2t, I'll slide this back to 0. And let's see this play out. So here our r is decreasing down to 0 at pi over 4. Then from up to pi over 2, our r is getting more and more negative, down to negative 4. Now as we increase our angle, our r is getting less and less negative until it is 0 at 3 pi over 4. And now our r is getting more and more positive until it is 4 at the angle of pi. And I'll just let this continue. Now r is negative, now positive once more, until we end up back where we started, and we would start cycling around again. All right, let's look at the next one. If you haven't worked on it yet, pause the video and spend some time with it. But let's talk about it now. All right, so r equals 1 plus cosine theta is our equation. And so to get our graph in the r-theta plane, we can just take our graph for cosine theta and just bump it up by 1. That's what this 1 plus is going to do. And so here we can grab a few nice anchor points, right, just by taking our old anchor points and bumping them up vertically by 1. And so here's what we get as we graph those 5 anchor points. Our last one gives us the same as our starting point. And now, reading off our instructions, between 0 and pi over 2, our r is steadily decreasing down to 1. So let's see, from 0 up to pi over 2, right, for our angle, our r, which starts out at 2, is going to be steadily decreasing and end up at 1 at the end. So it's going to do something like this. And now, moving from the angle pi over 2 to pi, r is steadily decreasing down to 0. So now, from pi over 2 up to the angle of pi, our r, which was at 1, is going to be getting less and less until it becomes 0 at the origin. So kind of as we rotate this angle, slurping in a bit, it's going to land us at the origin at angle pi. Now moving from there up to the angle of 3 pi over 2, right, so now we're ending up facing down, our r is actually moving back positively, getting more and more positive up to r equals 1. So if we do that, starting from looking along the negative x-axis and rotating down and come out more and more, we'll get this part of the curve, and that's when r equals 1, when theta is 3 pi over 2. And then the last stretch here from 3 pi over 2 to 2 pi. So we increase our angle that way. What is r up to? R is getting more and more positive. It's increasing up to 2. So as we kind of move our arrow, our r is going to be coming out more and more until we get to r equals 2, which will land us back where we started. And so we get this sort of sideways heart shape. It's actually called a cardioid because it looks like a heart. And let's take a look at that with our interactive. So we slide this back, change our function to 1 plus cosine t, and we let the movie play. And so r becomes 1 at pi over 2, slurps into 0 right at the angle of pi, and then becomes more and more positive. It increases, becomes more and more positive as we continue increasing our angle until we get back to r equals 2 at theta equals 2 pi, and then we'll continue around if we could slide this even further. All right, last one today. R equals 1 plus 2 cosine theta. Again, if you haven't worked on this one yet, pause the video, spend some time with it. It's a good one. But here we go. Let's dive in. So here, the way we can get the graph of this equation without using our calculator, just with thinking about graph transformations, well, if we first graph 2 cosine theta, which is just our standard cosine, right, scaled by 2, and then we just need to bump that up by 1. All right, so here, taking our standard 2 cosine and then just pushed it up by 1. So here, this point actually has vertical coordinate 3. And this point here, coming up from 0, would actually have vertical coordinate 1. And then this point here, it's coming up from -2, so this would have vertical coordinate -1. And so on. And so we can grab our nice anchor points here, and we get something like this. At this point, it's not clear at all how to connect the dots. Well, let's talk through it. And looking at our angle moving from 0 to pi over 2, our r is steadily decreasing down to 1. And so here, from angle 0 up to pi over 2, our r is steadily decreasing down to 1. So we're just going to get something like this. We're kind of slurping in as our arrow moves. For the next stretch, from pi over 2 to pi, as we're moving that way up to pi, notice we end up at our anchor point at pi for theta, and r is -1. So we're actually pointing behind where the arrow is, getting this point. But notice something happens in between these two anchor points, we have a point when r is 0. And so that's actually going to give us a point. We don't just kind of like slide around here and miss the origin. We're actually going to hit the origin at some theta. All right, and if you look past this curve, we're going to hit r equals 0 again at another theta. And so actually, before we connect the dots from our second to third anchor points, we need to answer the question of, well, what thetas do we get r equals 0? And well, that question, well, what thetas do we have r equals 0, gives us an equation, right? Here is r up top. We want to know when that equals 0. So we can solve this equation like any other equation involving trig, just hope for the best. Well, here we can actually solve for cosine. Subtract the 1 over, divide by 2. And actually, we can now think about this geometrically. We're wanting to know the angles when cosine is -1/2. And so if we bust out our handy-dandy unit circle, right, cosine is -1/2, telling us that the x-coordinate on the unit circle is -1/2. And well, what angles does that happen at? That's going to be at pi over 3 and 2 pi over 3. And so those are our solutions here, at least between 0 and 2 pi. And so what that means is that up here, our curve is going to slurp in and give us the origin as soon as we hit these angles. And so let's see what that looks like here. If we kind of toss these in, or these kind of special angles of 2 pi. If you were confused just a moment ago by my saying pi over 3 and 2 pi over 3, excellent work. Those are wrong, are they not? This pi over 3 is in quadrant 1. This is actually 2 pi over 3, and this is 10. So 3 pi over 3, 4 pi over 3. Just testing y'all. There we go. And so now, if we come in and graph these correct angles, there's 2 pi over 3 and 4 pi over 3. We see that. So now, maybe we can include those here in our getting very busy graph. Here's our 2 pi over 3, and here's our 4 pi over 3. All right, between pi over 2 and 2 pi over 3, that's when our r slurps down to 0. So here, between pi over 2 and 2 pi over 3, our curve is going to be slurping down to 0. And so we're going to kind of hug along this way. As we move to the right, we're slurping in more and more. We get sort of this action going on. Now, as our angle increases from 2 pi over 3 to pi, now what's happening to r? Well, we're coming out more and more negative until we get to -1. So here now, as we increase our angle, we're going to be moving out more and more negative. It's going to be doing something like that. Now, as we let our angle move past pi to 4 pi over 3, we're going to get sort of this action in reverse. Right? So now our angle is moving from pi to 4 pi over 3. And our r is getting less and less negative, so we're kind of slurping in. And so we're going to get sort of this sort of inner loop where we hit 0 again right at the 4 pi over 3 angle. And after that, moving from 4 pi over 3 to 3 pi over 2, our r is increasing up to 1. It's going to be kind of getting more and more positive up to r equals 1 when we're facing straight down. And then finishing the rest of this, increasing our angle from 3 pi over 2 to 2 pi. our r is getting more and more positive up to 3, and so it'll be coming out more and more up to 3, and we'll actually connect back up with the point that we started at. Let's see that with the interactive. Let me rewind. So here we are as we increase theta. Our r is positive, but getting slurped in. Here r is 1 at pi over 2. It becomes 0 at our 2 pi over 3. Then becomes negative, so we're popping out the dashed sign, the negative side, more and more until our r is -1. Then we start slurping in. Our r is closing in on 0. R is now 0 at 4 pi over 3, and now we're going to get more and more positive as we increase our angle until it is 3 again at 2 pi. All right, well, those are the 3 main ones for today. As an added bonus, graphing the solution set of r equals theta is a good time. I encourage you to play around with that for a moment. But otherwise, good work today, everybody. If you have any questions, post those to Piazza, and I'll see you next time.